Welcome to the Math Record. Today I'll be covering the ICTM Regional 2018 Division AA Geometry. I'll be splitting this contest into three parts. In this video, I'll be answering question 4 and 7. In the next, I'll be answering question 10 and 11. And then the final one, I'll be answering questions 15, 16, and 20. As usual, take a minute to scroll down all 20. Okay, so that's all 20 questions. And I'll give the answers at the end. So let's begin with 4 and 7. So 4. The line 2x plus 3y equals c is tangent to the circle x squared minus 2x plus y squared plus 4y is equal to 95. There are two values for c, and then they ask for the positive value of c, and it's in this form, and we have to find the sum of the coefficients, basically. So first, we need to rewrite our circle, so then it's in vertex form. It's usually easier to understand circles in vertex form. So then it will be x minus 1 squared, because negative 2 divided by 2 is negative 1, so I know that's a 1. And then 4 divided by 2 is 2, so then this is plus, that looks bad, plus y plus 2 squared. So that's a plus 1, that's a plus 4, so that's a plus 5 when it's squared. So then we have to add an extra 5 to that 95, so that's 100. And 100 is just 100, it's just 10 squared, so our radius is 10. So if we have to draw a diagram of how this looks, oops, okay, something like this. And the center is going to be at negative 1, at 1, negative 2, so somewhere like right here. Actually, 1, negative 2, somewhere like right here. And then it has a radius of 10, so we have some kind of circle like this. I'm not really good at drawing, so basically just think of this as a circle. And then basically, there is a line that's 2x plus 3y. And if you think about it, the slope is just going to be 2x plus 3y equals c. Move the y to the other side, so that's negative 3y, right? And then divide by negative 3, so the slope is negative 2/3, right? In front of the value of x is your slope. So if our slope is negative, then it's going to be something like this over here, or something like this over here. So if we want a positive value for c, we got to look at the top one, right? Because if you put two positive numbers here, then we get a positive. If we put two negative numbers for x and y, then we get a negative right here. So it's definitely going to be this line. So looking at this line, what we have to do is when its tangent is this point right here. So we need to find a point for x and y, so then we can get c. So I know that this is radius 10, and I know this slope is negative 2/3. And since this line and this line are perpendicular because it's tangent, then I know this slope is opposite and reciprocal. So this slope is going to be 3 to 2. So that means the height to your change in y to your change in x is 3 to 2. So let's call this 3x and 2x. So that this is in that ratio. And I know that the radius is 10. And I know that this point is 1 comma negative 2. Okay. So I know this is 10, so we just need to scale up our 2x and 3x. So that's 2x squared is 4x squared, 3x squared is 9x squared, and that will give us 13x squared is equal to 10 squared, which is, let's just write 10 squared, and then take the square root of both sides, so square root 13x equals 10. So x equals 10 square root 13 over 13. So we know that value. So we know our x, let's delete that because we don't need it. And now we have our x. And now we know where this point is that goes through this line. And that point is just going to be from 1. Our x value is from 1 plus 2x, and plus 2 times this x is 20 square root 13 over 13. And this is our x value. Now we need to find our y value. Our y value starts at negative 2 plus 3x, so 3 times this x, which is 30 square root 13 over 13 equals your y. And now we have our two values for x and y, so we don't need this diagram anymore. And now we just need to plug these points into 2x plus 3y to equal c, right? So just plug them in. And you get 2 plus 40 square root 13 over 13 plus 3 times negative 2 is negative 6 plus 90 square root 13 over 13. And then 2 and negative 6 makes negative 4. And 40 plus 90 is 130. 130 divided by 13 is 10, so plus 10 times that square root 13. So that gives, so if we had to put a coefficient on the bottom, it's just 1. So then our k is negative 4, our w is 10, our p equals 13, and our q equals 1. So add them all together. So negative 4, negative 3, 7 plus 13 is 20. And that is our answer for number 4. Okay, number 7. Quadrilateral ABCD is a parallelogram. Q is a midpoint of AB. So let's actually kind of draw this diagram first. So we have some kind of parallelogram and a line and another line. Okay. And they say that Q is the midpoint of AB. So this is the midpoint. And they say R is the midpoint of QB. I mean, Q is the midpoint of AB and R is the midpoint of QB. So that tells us that if this is a side length, this is a half of that length. This is a fourth of that length, and this is also a fourth of that length, because half of a half is a fourth. And then S and T trisects DC. So we have, since it's a parallelogram, this length and this length are the same. So we could just call this also L, but it's cut into thirds. So 1/3 L, 1/3 L, and 1/3 L. Okay. And now we just need to connect a bunch of other points together. So we have this to here, and then here to here. And we also have from here to here. And they're saying they want to find the area of quadrilateral AESD, so this area, to, and to the ratio of RET, so this area. So this quadrilateral to this triangle, basically. So we need to find that ratio. So what we know from a parallelogram, if we kind of think about it, let's just split this quadrilateral into 2 triangles. So let's use red, and I'm going to split it right here. Okay, so now we have that line. So if the triangle right here is a base of has a height h, right? It's just base times height. So if this 1/3 of this length, and this is also 1/3 of this length, what it tells us is that these kind of triangles have the same area. So if I label this as 1/3 of the length times the height, 1/3 LH, then this triangle, right? So it's this triangle plus this triangle is also 1/3 times height, and this triangle plus this triangle is also 1/3 L times height. So, but let's first find out what this small triangle is. Okay, so if we call this length a triangle of area, let's say A, right? Let's look at this. We have 1/2 plus 1/4, that's 3/4 L. So this entire length is 3/4 of this uh, length of this parallelogram. And we know that these two triangles are similar because these are these are vertical angles, and also these are alternate interiors, so these two angles are the same, and also these two angles are the same. So like that. So it's kind of like that. So that tells us is that this side is similar to this side, but it's just scaled up. So what we could say basically is if this is 3/4 L and this is 1/4 L, then this means this triangle is scaling up 1/4 to 3/4 is 9/4. So that means the side length is 9/4 the ratio from this triangle to this triangle. That means the area, it will be square of that. So it'll be 9/4 squared, which is 81 over 16a. So that's just the idea of similar triangles, and they have similar areas. So now we know that this area, right, is 1/3 LH. So we could just have 1/3. It's kind of hard to write, so I'll just write it outside. 1/3 LH minus A. And this is also 1/3 LH minus A. And now we could think about this again. We know that this triangle also has a height that's h. So, but this is 4/3. So we know that this area, which is 1/3 LH minus A plus 81 over 16A, 81 over 16 times A is equal to 3/4 L times your base times your height, which is h. And now we could find LH in terms of A. So then we get 1/3 minus 3/4. So that is going to be 4 over 12, and this is 9 over 12. So this is 5 over 12, LH. Okay. And 81 minus 16, this is just 16 over 16. That is equal to 65 over 16A. So then that gives us our ratio between A and LH. So let's delete that, and we get this. And now we can add all these numbers together. So the ratio of our quadrilateral to our triangle, our quadrilateral is 1/3 LH plus 1/3 LH, so that's 2/3 LH plus a negative A. And then the area of our triangle is 1/3 LH minus A. Okay, so we have our ratio, and now we just need to substitute our A with our LH, and we just get our answer. Okay, so we need 2/3 of LH minus an A, which you could just kind of move over. You can multiply both sides by 16 over 65. 16 over 65, 5/12 LH equals our A divided by 1/3 LH minus 16 over 65 times 5/12 LH. Right, so we could just cancel our LHs because they will divide out. And now we just need to find this value. So let's just simplify some of these values first. So cancel out the 4 here to make a 4, cancel a 4 and make a 3, cancel out the 5 to make this a 13. So then this would be the same thing as 2/3 minus 4 over 39. And this would be, cancel this out, that's a 4, that's a 3, 5, and this 13, so 1/3 minus 4 over 39. So then this would be 26 over 39, so that's subtract 4 is 22 over 39 over, and this would be 13 over 39, so minus that, that's 9 over 39. So divide those numbers out, and you get 22 over 9. And that is your answer for number 7. So it just takes a bunch of similarities to work with. And that basically covers the first part of our 2018 AA geometry. And as promised, here are the answers for all 20 questions. Well, thanks for watching.